So yeah, this is a pretty interesting topic. I think those of us who have been in the industry for a long time are used to trade-offs between bottlenecks. And when I was thinking about this topic, I think there's actually two different kinds of bottlenecks. There's bottleneck from a standpoint of orchestration, which you guys were just talking about. How do we fold networking, full network services, rich network services into the orchestration? There's not too many people that are doing a good job of that, but I think some of the ones are up here on the stage. The second is really about bottleneck from a throughput standpoint. And from a throughput standpoint, I think about the amount of time it takes to move a petabyte of data from the east to the west coast. It takes a pretty big-ass network to do that. 100 gigs, and it still takes 24 hours to move a petabyte. It's not that cheap. And I know most enterprises don't have those big fat pipes. One of the things when I was at a prior employer at Equinix, we were embarking down that road of getting enterprises to build into carrier-neutral facilities for that reason, because today, I won't name any names, but I can buy 100 gig wavelength anchored at a carrier-neutral facility from the east to the west coast for under $20,000 a month, if you know how to buy it. And that's what companies like Google and Facebook do, so we can afford to move all this data around. We go out to, I just flew in last night from ITW. That's one of the big conferences around the world where all the big content providers have been showing up for the last 10 years. I saw buddies from Twitter there, I saw buddies from Netflix there, Google, Facebook, and so on. But I didn't see a lot of enterprises that know how to crack into that. So as we I'm going to introduce these guys and have everyone kind of talk about what they do and what their unique angle is on this topic. But as we look at this, I think there's really three different big areas we want to talk about today. One is, what's the bottleneck inside the data center for storage and networking inside the data center? The second one is really, what's the bottleneck look like between data centers, right? Because we can't just have data stored in one place. We're a global infrastructure these days, right? And the third is really, what's the bottleneck from a flexibility, orchestration, dynamically moving network resources virtually to match the storage and the workloads that we want to match them to. So Tom, why don't you get started? Introduce yourselves.
Thanks. My name is Tom Etzel. I'm the CTO of the NCME Business Unit and a Cisco Fellow. My career has been built around building networks, and sort of my angle on this is that it's either a law of physics problem, or it's a case where our demand for bandwidth has exceeded our refresh cycle. So the technology may exist, but you may not want to throw away the switch you just bought last week in order to keep up with it.
And I'm Alvin Sequeira, Senior Vice President, General Manager for VMware's Cloud. Prior, I had led a lot of the work with network virtualization, NSX, and more recently have been involved with making enterprise networks and the cloud networks look seamlessly joined to each other. So you have to work through the physics of compute, storage, networking, on-prem, off-prem, through the WAN, data center, et cetera. So those are some of the issues we've been tackling over the last few years, if you will.
Yes, I'm Roy Kaser. I'm the CTO for the CSB division at Hewlett-Packard Enterprise. A large chunk of my background has been in the telecommunication area. Have started to bridge that into more of the enterprise and data center space as we start to see those technologies converge. We really come at this from a perspective of a disaggregation of the network to try to get where we can make it more flexible, more dynamic, programmable, where you can bring in the components that fit best so that you can get the right compute, the right storage, the right port availability for the workload that you're going to do. And it was interesting, the topic that was before this, we've also started to look at the fact that memory and storage are becoming one and the same. So how do you start building architectures that leverage off of that as well?
Hi, I'm Andy Warfield. I'm one of the founders and the CTO at Coho Data. I'm the other token storage guy in the room, I guess. I guess I come at this from the perspective, I was one of the authors of the Xen hypervisor, so I was a virtualization guy ahead of this. And looking at the way that storage technologies are changing, they're becoming fast, very, very fast, in sort of a problematic way. And so from my perspective, storage is less what it has been for 30 years, which is a redundancy and availability problem, and suddenly it's a connectivity problem. And so the product that we built at Coho actually takes a storage system and includes SDN networking, right? Reaching out into the network as part of how we make that very, very fast, diamond-like performing storage connect out to the rest of the data center.
Hi, I'm Dave Meyer. I'm the Chief Scientist and Brocade Fellow. Over the last many years, I think I know a lot of you. I've worked on recently SDN, orchestration, and before that, I've worked on many, many different kinds of things. And I was just thinking about what Stephen and Doug were saying about compute, storage, and network. You know, choose two, better, faster, cheaper. People want to choose three, actually, right now. But it might be that there are five: compute, storage, networking, security, and energy. And all of these things somehow have to orchestrate together. And that's kind of what I've been working on recently.
All right, thanks, guys. Okay, so I want to tackle the first piece of this, which is bottlenecks inside the data center architecture. One of the things at Yahoo, we have these big Hadoop clusters that run on, several thousand 10 gig attached compute nodes, and Hadoop does a good job of kind of putting storage and compute together. We find that those machines pretty much peg the 10 gig ports. We're looking forward to things like 25 gig Ethernet with commodity 100 gig uplinks from that. So kind of just a refresh of that leaf spine architecture. But I'm interested to hear, especially with flash storage, has 100 times the IOPS of a spinning drive. What do you guys see inside the data center for the next kind of breaking through the bottleneck? You want to take that?
Sure, I'll start on this. I think there's maybe two ways to think about the change that we're seeing with storage. One is the old systems that are moving onto new hardware, and then the other one is the new systems that are being built as a response to the new hardware. So the first one of those is the fact that for generations we've put storage at the end of the row, right? The disks have been spectacularly slow, and you don't really worry about the connectivity traffic into it. The reality of the hardware that you buy today as NVMe flash means that I can saturate my link out of the TOR up into the spinal core with about 4U of devices, right? And that's falling to 1U of devices and less very quickly. And so that connectivity problem means that suddenly topology is really important. I think the second one is all developers on the software side have been taught for years and years not to use storage, right? It's so slow that you should write applications that stay in RAM. And that is changing faster than any of us realize. And so as applications shift to start to more aggressively use their data, it's the network that's going to really pay the price on that.
What's the speed out of your appliance?
The appliance we sell today is 4 times 10 gig, and we can do 4 times 40.
Okay.
Yeah. Per node.
Tom?
Yeah, so my position on this is, it's not that the technology doesn't exist. We could put 100 gig into the top of rack, and we have switches that are 36 ports of 100 gig, 32 ports of 100 gig, and you'd be surprised that they are not extraordinarily expensive. But it's unfortunately you have to upgrade pretty much your entire infrastructure. If you have that bandwidth in the top of the rack, well then where is it going to go from there? And so it is a big refresh problem more than a technology problem, in my opinion. And as their demand will increase beyond the 100 gig, we'll have the 400 gig, and we'll do the 1 terabit. I mean, that's the way it has always gone. It's very, very challenging. We see that the network bandwidth goes up by an order of magnitude about every 6 years, and that's a pace that is faster than Moore's Law. And so we are challenged on the technology side of things, and so we're addressing this with architectures. All of you are also addressing this with architectures, and you are as well. As we go from a leaf access aggregation core, we go to a leaf spine topology. That's an architectural way to address bandwidth and how do we get more cross-sectional bandwidth. And we will continue to see architectural approaches to address this.
Dave?
So one way I've been thinking about this problem inside the data center anyway is the question is whether or not we can take compute to the storage and kind of alleviate some of the pressure on the bandwidth that the network has. And I think there's a lot of opportunity to optimize around that. And right now, I think that's just starting to happen at scale. And I think we'll see a lot of this kind of the migration of compute towards storage or towards the gravity that storage has in order to alleviate this problem. And it's sort of a different angle on it. It's sort of a virtualization angle.
Yeah, I think just to leverage off of what Dave said, and Tom said earlier, the technology's there. So at some point, the speed and feed play is just going to gas out. If it doesn't gas out because of Moore's Law, it's going to gas out because of the refresh cycle. It's going to gas out because of the economics. And so to Dave's point, you're going to have to start building more and more flexible networks so that you can, in fact, adjust the network. You can stripe the network. You can use the applications to define where do you need the bandwidth when, and shift those resources so that, if you look at it today, almost everybody's over-provisioned, but at the same time, while they're over-provisioned, everyone's complaining that they're not getting enough throughput. So we've got to do a better job of the automation and the aggregation, and we have to get smarter about where we put the data and how we use it. And like I said, in my telco background, when we look at this and we're coming into 5G, you look at what used to be 100 millisecond latencies were fine across the network. Now we're talking about 1 millisecond latencies across the network. And the only way you're going to do that is start doing more and more of your work near the compute, near the edge, so that you don't have this petabyte of data all of a sudden that you have to worry about. You've actually partitioned it. You do the work where you need to do it, and then that intelligence that you boil out of it, then you can start to centralize some of that. So, it's a multi-dimensional problem. There's not one silver bullet for it, and you're going to have to look at what all the different arrows are in the quiver that you can leverage off of.
Yeah, Lade, for us at VMware building a cloud, our cloud is slightly different than your pure cloud-native apps clouds that a Google or an Amazon would hold. Our clouds are meant to replicate data centers on-prem and tie back to the enterprise use cases. And our finding when we initially started was all homogenized. Compute and storage worked in lockstep to each other and created the pods. But over time, what we began to realize is, depending on the use case, orthogonal growth rates of compute and storage. What that means, that initial lockstep of interlocking of compute and storage and so-called hyperconverged. What are you hyperconverging? Is it on a rack basis? Is it on a pod basis? This becomes incredibly important. The thing I've come to realize, it's not about hyperconverged racks, because you will never get to a nice rounded out model where compute and storage are in sync. So we landed up having to map customer use cases and applications, because ultimately most of these apps tie back to some system of record, which is your conventional databases sitting on-prem and bringing the data into the cloud. And in the cloud, you have various different applications. A desktop as a service application tends to have very homogenized disk requirements. So you can use your existing disk-attached storage. On the other hand, a backup application or a disaster recovery application or a three-tier app NFS storage are very, very different use cases. So having to map the application virtualization infrastructure, building a physical infrastructure that's relatively homogenized, but having a logical network virtualization layer, which we've landed up doing, leveraging NSX and all of the microsegmentation and all of those logical goodness, but mapping that in real time to map into the specific use case, the application use case. That's what it's come down to us. And ultimately, there's a huge impedance mismatch between the WAN speed, the top of the rack, and the spine. And keeping these in sync, I think, for us is a larger problem than the sheer feeds and speeds of any given link.
Thanks, Alwyn. Hey, so that's a lot of different viewpoints. What I want to ask is a real simple question, and I'll open it up to the audience as well. What is, when you look at flexibility of the infrastructure to reconfigure compute to be associated with storage, let's say I've got a bunch of storage and I have some compute that works during the daytime, and I've got some other batch jobs that want to do a lot of high IOPS on that storage at night for some analytics. What is the amount of time, what time scale are we talking about these days as kind of aggressive for taking a node, either wiping it or creating the VM with the image that we want, putting the apps on it with Chef, orchestration, or whatnot, and then checking it into the whole system, doing the whole service chaining, and putting that node online? Are we talking minutes? Are we talking hours for flexible availability of shifting resources?
So what we find with our customers is that there's they have all different abilities, and so what is the top end of that? It's minutes, and we have a number of customers that have achieved that, but it's pretty challenging. And what we see happening moving forward with containers, that it's going to be seconds. And in fact, the lifetime of the application may be seconds, which creates, I think, a much bigger set of issues around the data center than bandwidth bottlenecks. So we see the full spectrum, but there are certainly, I would say, most of our customer base has not yet migrated into an SDN environment, has not done all of that automation, and they are still working on this order of days. And so while the people in this room and the people that come to this conference have been thinking about automation and thinking about software-driven things for a long time, you actually represent a pretty small slice of the entire market. You guys are the leaders.
So Tom, one place I've seen the seconds already is in sort of what's being called mobile edge computing, where you want to set up service chains for really short flows. And these flows might last a few packets or so, right? And so now what you're doing is taking compute somewhere, setting up service chains, and tearing them down within seconds.
And then if something goes wrong and you got to go debug it, and it's like, well, the application doesn't exist anymore. How can I figure out what's going on?
Yeah,
and so visibility is a huge, huge issue.
For us in building out our vCloud architecture, again, comes down to which layer. The physical layout obviously takes months or whatever to bring up and set up. Then we have a virtualization layer. We spray paint compute virtualization, network virtualization. We are today 100% SDN network virtualization based inside a cloud center. On top of that, you layer the cloud provider services, and ultimately it comes down to the tenant services. At the end of the day, the tenant services, that's got to be really fast and agile. And the other thing that tenants do want is both day zero and day one provisioning. On day zero, you want to be able to pick up a license, you want to be able to craft your virtual data center that might have a set of VMs and a set of logical networks that might be connected with a set of routers, an edge router, firewall, VPNs. All those things today, the good news is all that can be done in a matter of seconds and minutes. But further down the stack you go, you want to be very careful and diligent about getting that turned around too often. But I think the good news is in this, with the forums like this over the last few years, we've taken network virtualization to a point where you can programmatically stand up an entire application landscape or even a tenant virtual data center in a matter of seconds and minutes.
All right, thanks, guys. So, yeah, go ahead.
Hey. I'm interested with the at-scale deployment of NSX in that environment. In that, I wonder with the end-host virtualization, how much of a problem does the lack of physical topology represent? Like if you need to plumb a few hundred gigs from one side of the network to the other, is that something that you're having to add? Is that a challenge for you guys?
Ultimately, obviously, you cannot go faster than what the underlying top of racks and spines will allow. So we tend to leverage the latest and greatest physical infrastructure, whether it's your top of rack switches, leaf and spine mode. But assuming you get 10 gigabits or 100 gigabits bandwidth there, we overlay things like VXLANs on top of it, build end-to-end long wires across the data center, and then you have provider scope and tenant scope built and overlaid on top of that. Yeah, so the physical is all set up and wired, and then you have these logical networks that you then provide different namespaces for different tenants, and that can be programmed on the fly to map into the tenant requirements.
ACI technology does a very similar kind of thing. And one thing about inside the data center, I think it was a comment about network latencies of milliseconds. It's actually a handful of microseconds is the latency on the network, just to clarify that.
One thing this discussion has kind of illustrated is something we were talking about earlier is this topic seems to run into problems with physics all the time. You know, it's like you can't go faster than whatever it is, 24 hours for a petabyte on 100 gigs, right? You just can't go faster, you know, so.
Well, but there's a there's a key number to bear in mind in terms of physics. Tom, you were mentioning that you see an order of magnitude speed up in 6 years. Was the fact on the networking side. The same 6 years has seen a 3 order of magnitude speed up on the storage side, right? So it's quite a change in the impedance mismatch between those things.
Yeah. So my numbers come from the bandwidth of a line card in a switch. That one single line card. The bandwidth of data centers, I don't even know how to measure that. You know, it's like how deep is the river? It depends on where you're standing. But I suspect that it's because of drivers like storage, because of drivers like massively scalable applications, ridiculous parallelism, all of those things. I mean, I'd be curious to know what the audience thinks about what is the bandwidth scaling rate of data centers? Or is that even a meaningful question? I don't know.
Yeah, we have a question here.
Storage, and we recently ran a POC where we were able to do IB reads at literally 40 gig off a single host, no CPU utilization, nothing. Is data locality, and you mentioned Hadoop also, is data locality becoming a really important thing, and how are you guys working on data locality in the context of trying to reduce bandwidth consumption?
So in our case, this actually leans kind of on the question I was asking earlier, that it really comes down to understanding physical topology. So I think that data locality is important. I think that the relative round trip time at tens of microseconds between hosts and tens of microseconds to the device, to the storage device, are in the same ballpark today. And so you're having to think about these things to get value off of the hardware, off of the storage hardware.
Yeah, I think this is a really foundational and important question. I remember talking to a huge financial. They spent years building up an entire cloud system across the world, distributed compute cloud. Except that and it all worked beautifully and orchestrated, and they were able to spin up VMs everywhere. Except when it came real time to bring this up and alive, it turned out that data is the major issue, right? So ultimately, it's you take the cloud to the data versus the data to the cloud, because there's petabytes of data that's sitting out there in all various shapes and forms. Some of the data is regionalized, some of the data is not applicable in different places. You can't replicate the data, etc. So data seems to be the grounding point, the planet, if you will, and compute are the moons around the planet. And we see the same thing happening inside of our data centers. Once a tenant has spun up a cloud instance and they start building up the data there, it's very hard for them to move from that point on. So data gravity is a hugely important concept, and so we have to work the network and work the topologies around data versus the other way around.
Yeah, I think that's a good question because when I talked about intra-data center, we also talked about inter-data center, right? And that's where you really get into the issue of storage gravity. As Dave said, with a 100 gig link, it still takes you 24 hours to move 1 petabyte. We recently at Yahoo were having some discussions about some edge cases of our infrastructure, just a portion of our infrastructure. We wanted to move 100 petabytes or so out to an external cloud provider for stuff that was kind of least frequently used type storage. One of those providers said they have something called Snowmobile. AWS has something called Snowmobile. Have you guys heard of it? They basically take a truck full of snowballs, right? They take a truck that comes out, has 100 petabytes in the truck, has about a dozen single mode fibers out that can do either 40 or 100 gig into your data center. And we're still at that point where FedEx, or the FedEx equivalent, is the fastest form of bandwidth available between data centers for massive amounts, right?
Call that sneaker net.
Right, sneaker net, yeah, rubber net, or whatever, tire net, whatever you want to call that. So I think that that is a very big issue because the ingest problem, as I call it, is you want to move it once, but from then on, you're only going to move incrementals, right? I think what you see in the cloud space, like Google or Facebook or so on, is the application is multi-site write from day one. Every operation is being written to a cluster of geographically dispersed data centers from day one. So you never have to move a large quantity of data ever, unless you're creating a new data center and need to resync a bunch of apps into it. But that's not true in the enterprise world. It's just simply not true. So we still have this issue to solve.
There's a really actually interesting property about the Snowmobile stuff, which is that copy, right? That bulk copy of all that data is something that the storage teams in most enterprises spend all their time doing, right? Because they have tens of petabytes of data, and they're always retiring some subset of it onto new shelves full of disks. And there's this huge tail of low access data that these guys are just always moving. And so being able to encrypt and ship that warm data into something that they can access without having to do 5-yearly refresh is just as important as the high performance tier of storage at the top, right? It's a really interesting thing, but it moves all of that relatively low rate traffic onto the WAN.
So I think that on that topic, it really does come down to laws of physics, and I think enterprises do have to really take seriously their WAN infrastructure, how they're going to get to better ownership economics on that. Even for WAN scale, I think, I'd be surprised if you were a data-intense Fortune 100 or Fortune 500, why wouldn't you have a plan to have a 100 gig wave-based backbone, right? And why wouldn't you go figure out how to source that kind of thing from, and copy the best practices of companies like Facebook or Google in that area? Because it's actually not that expensive. You'd be surprised.
Yeah, I just would add to that. One thing that we've all been talking about in the industry with SDNs, and I've been saying it as well, leaf spine topology, you're looking for homogeneity, and Alwyn was talking about this as well. For a rack that's containing storage, maybe it needs more bandwidth than a rack that's just compute. And so we may be moving away, and it's to some degree, from that homogeneity, that you may build that topology, which means you have to be aware of the topology. If it's no longer uniform, it matters. And that can be a bit of a paradigm shift. And that's one of the challenges that I see with a lot of the orchestration tools that are out there, that they don't take into consideration the network topology. And they just sort of assume that there's just connectivity, and that's not going to be enough moving forward. So, as I've been saying, yeah, you can throw 100 gig links at this. It's a physics problem. You got a big thing. You got to shove down a small pipe, or you want to do it faster, you get a bigger pipe. But it's not going to be economical to provide that pipe everywhere, and you don't need it everywhere.
Mm-hmm. I want to ask you guys about NFV, because when I think about this problem, from my own experience over 2 or 3 different past roles, it hasn't been so much the top of rack switch that's the bottleneck or the leaf spine, or even if we have a super fast backbone router with some pretty fast links on it, it's always been my experience that the bottleneck is in the middle boxes, like the NFV stuff. It's like, oh, well, the firewall can only do so much, or the load balancer can only do so much, or I got to put IDS in the service chain, and that's a bottleneck. So how do you guys solve that?
Yeah, I just over the last few weeks, I've been talking to several NFV partners, and many of them are beginning to enter. We've been in the virtualization world for a long time, and folks are beginning to talk about, let me take my router and run that on the cloud or run that on virtualization infrastructure, but I have this 20 gig pipe. Are you able to support it? It's almost the wrong question, because the one thing you've realized if you've been in virtualization for a while, there are two kinds of traffic. East-west traffic. East-west traffic has to scale with the number of hosts. So that's the only way to really scale out your networks. In other words, if you have hundreds of hosts, you need to have firewalls and load balancers and routing that scales with it. The only way to do that is to have smaller elements that are highly scaled out. Now, it's a different thing in north-south, leaving the building, leaving the edge, in which case a scale-up architecture matters. So sometimes I look at a lot of not-so-good designs with NFV where you think you're going to take what you used to have as a pizza box or a box that ran on bare metal and virtualize it, and there you have NFV. It's not so. There has to be some re-architecture that needs to be done to create a scale-out with a single control plane, but multiple data planes that are effectively virtualized and scale to the level of the VNIC or what the capability of a given VNIC. So in other words, the east-west architecture and NFV call for a slightly different architecture than an edge kind of NFV device. At least that's what I see.
Yeah, I kind of agree with that. I mean, I think the answer probably to your question, or at least in part, is what was just said, which is basically you have to be able to scale out. So that means you have to be able to orchestrate. That means you have to be able to do all the things that implies. So.
Yeah, and I was going to say, you still have to be telemetry aware, as we were saying before. And when you start doing service function chaining, you need to start becoming a little more intelligent in how you do it, and you do it per flow as opposed to per pipe or per VLAN or whatever. That way you're not funneling all this traffic through a load balancer, frankly doesn't need to be there, or through a particular firewall or whatever the access is. So if you can start doing that per 5 tuple per flow, then you can start really scaling up pretty effectively.
Okay, thanks. So on that, a couple observations here. One is that definitely from what I've seen at Yahoo, we have a whole bunch of developers that say, hey, you know what? It's super easy to develop on AWS. So there's internal pressure to make sure our own internal PaaS layer is that easy. But frankly, that agility that developers get, I believe the battle is really about who has that best orchestration layer, or that best stack, right? Who gives the whole solution so that the developers it's super easy for them. You abstract a bunch of problems away. However, you do get into that situation where it's easy for the developer, but then the cost can really mount as it scales. So I guess first on the topic of elegance of the stack, I'd love to hear you guys talk about how that makes it easier for people to utilize their infrastructure. But second, do you think something like Intel DPDK should become a unit to acquire within AWS, or do you envision that being harnessed inside your own stacks? So kind of that, how do I get 40 gig of deep packet inspection type capability out of every Intel host?
So just taking the latter question, and it's not really an area that I'm directly involved in, but Cisco recently released into the open source something called VPP, which is gives you a similar functionality to DPDK, and take it, use it. It's out there. I think it's fm.io. I don't see.
It's FIDO.
Excuse
FIDO.
me.
FIDO.
FDIO. There you go. So you know more about it than I do, probably. Yeah, we see that as being something that will be more widely used. As far as orchestration go, yeah, I think orchestration is hugely important. Any problem in software can be solved with another layer of indirection. This is another layer of indirection, so we'll solve all our problems. But it clearly, the abstraction is going to allow us to automate more and get a handle on things. Certainly for the provisioning and orchestration, sort of the day one step of things. It's the day two and day three where you're dropping packets and you need to understand why, and then you got to go pretty deep. And right now, I don't know that those orchestration layers are giving sufficient visibility at a low enough level to really debug a network.
So I'm not sure which, when you were talking about AWS being, excuse me, I don't think you used the word sexy, but we haven't used the word sexy yet, so why not? In terms of its orchestration, I don't think it's so much that it's more elegant. I think it's more available, easily available, right? Like I said, if you're a startup company or you're an organization that's just starting to venture into that, the spin up of CapEx, the spin up of expertise. I mean, we can pick a number of really large carriers that decided they were going to stand up on all their own clouds and orchestration and failed pretty miserably. So I think it's a nice jump start. But as you say, once you kind of get hooked on that, it's a little bit like an addiction that you got to figure out how you're going to unwind yourself when you really need to go to scale, because the total cost of ownership, I think, is going to become a problem for you. Along with DPDK or SIROV, any of those things, sure, it's available inside of AWS, but it's available with most all the OpenStack instantiations at this point. And for it to become solely something inside AWS, that would be problematic. And I mean, we roll it out in our stacks, and the partners that we work with do as well. So I think that's going to be pretty ubiquitous to help us drive these throughputs that we're looking for.
Yeah, exactly. Things like DPDK and AES, we look at that as x86 extensions, and it gets inbuilt into software. That's the beauty of software, and anything that Intel does as part of the x86. So you've extended the stack, leverage that, and you get the ultimate scale out. But for me, the important thing about orchestration that's beginning to happen, people are going from just pure IaaS to things more prescriptive and opinionated, like PaaS layers, etc. You saw the $650 million investment yesterday in Pivotal from Microsoft and Ford and General Motors. What's becoming more and more relevant and prevalent these days is the networking aspects. Rarely is it that the developers want to program to the network layers or the storage layers. What they're looking at is a higher level construct in the context of their application, whether it's a Node application or Ruby or whichever the framework of de jure is, Angular, whatever it be. They're coming in at that layer, and at that point, the important question to ask is, do you need to just assume connectivity and filter out and create ACLs at that layer, or should we have a separation of concerns between the app layer and the underlying infrastructure, and just have the app frameworks map onto the underlying infrastructure as a service, and let the developers do what they do best, which is write their stateless apps and have it deploy at scale, and then have a late binding to the underlying infrastructure, whatever that infrastructure be. We see that happening more and more and more, a separation of concerns between the infrastructure as a service and the higher layers, where there's incredible innovation happening on a monthly basis, if you will, with the new frameworks in place.
There's a really neat divide here in that it's not clear exactly where that handoff should be. In that I agree absolutely with what you're saying about orchestration. We've had it happen a few times in the past couple of years. The large enterprises have said, could you guys please implement S3 on your storage product, because we can't hire developers that understand how to write code for POSIX anymore. Right? They don't know how to deal with files over NFS or iSCSI block devices. They want to write S3 code. So it's not that it's faster or better, it's I can hire people for it. And so I think that on a lot of these things, you absolutely want the top level orchestration to let somebody spin up a Kafka because they care about getting a Kafka. They don't care about getting an NFS file handle. But when that Kafka falls over because it can't get the underlying multi-tenant isolation that it needs at the bottom, they're stuck with a pretty hairy performance debugging problem. Right?
I just wanted to say one thing. It turns out that it looks like we're talking about orchestration like it's a fully cooked thing, right? You know what I'm saying? Well, I was just gonna, Yeah. I was just going to briefly allude to the orchestration kind of environment that we were finding in the telco space right now. It's pretty much of a free-for-all right now. And I think as a community, what we're trying to do is come together around something that has open, standardized interfaces, that has standardized kinds of, standardized not like in the internet standards, but open source kinds of interfaces that, that people have evolved to what they need. But right now, the environment is pretty chaotic. It's less so, obviously, in the enterprise space, but in the telco space, it's, as I said, not fully cooked.
Yeah, this is where having seen the evolution in the higher layers and the development community, I think we in the infrastructure world should really take and learn from what's going on out there. I think in the telco world, even in the infrastructure vendors, we're all too much caught into trying to put in place our own opinionated APIs and have everyone evolve to the APIs. That will just fail by all means. Rather, the world that's evolving to create some microservice infrastructure architecture that's loosely coupled with some RESTful APIs that seem to be where the world is headed. Things like WebSockets, TCP, those are the things that are lasting. So if the community, whether it's the NFV community, whether it's the infrastructure as a service community, rally behind certain constructs and create open source ad hoc implementations that's put out there, not worry about standards, not worry about it, but ad hoc developers coming together and rallying behind these things. That's the way of the world we seem to see succeeding there in a big, big way. And I think we can, in the infrastructure community, learn a lot from those higher layers, if you will.
All right, guys. So one last question. I actually kind of want to pull the audience here. 25 gig Ethernet. Plans this year. Raise your hand if you have any 25 gig E attached hosts that you plan to have. 40? 40? Okay. As 4x10? Okay.
We're also seeing 50. So 50.
50.
Going once.
Yeah, going once, going twice. Yeah, we don't plan to do mass deployments in 2016 at Yahoo, but 2017 we definitely see it's not being bounded by the end compute nodes. It is being bounded by when the top of rack and leaf spine switches are available that have the 100 gig uplinks at the commodity price points that we need. So it's purely math, right? It's the cost of X number of 100 gig uplinks should not exceed the cost of the equivalent number of 40 gig economics.
Yeah, right now the 25 gig links are going for the same price as 10 gig links did last year, and 100 gig is available for basically the cost of 40 gig last year. So these switches are available from us and from our competitors now.
Lane, when you talk about 25 gig and 50 gig, even to Tom's point, what is the oversubscription rate you look for at the top of rack? I mean, are you guys building a full mesh? Do you require a full mesh, or are you considering that, or is it a heavily oversubscribed as a 4-to-1 as an example?
Yeah. So we're doing, right now we do non-oversubscribed on the core. Within the leaf spine, we're 2.5 for 1. Yeah, especially for a Hadoop grid. You can't afford the bottlenecks because every host is almost pegging the 10 gig all the time.
Just a little more data points around that. I would say the typical that I see is a 3-to-1, and so you're a little richer. And then, but it depends on the number of tiers that you're building in your network. If a network is a typical 2-tier leaf spine, we're seeing 3-to-1 is a very common number. If you're going to 3 tiers, sometimes we'll see pretty high oversubscription ratio in the top tier, even 20-to-1. And in that case, you may or may not be doing oversubscription in the lower tiers, usually some amount, because the sooner you oversubscribe, the more you save.
Do you want to take questions?
Love to take questions.
All right.
Yeah.
Did you have something, Owen, on that topic?
No.
Okay, I'd love to get any other questions from the audience. I think we're pretty much almost out of time. I know we started a little late, though, so I'll be liberal if that's okay with you, Nick.
If we can land the plane around 5:15.
All right, perfect.
We have John Anthony Warren.
You've talked about faster networks, but more so the need of intelligent networks, better orchestration. As we see more traffic, we get more data about data. Visibility has been a recurrent theme. What do you see in areas around visibility, telemetry going forward? Short term, mid-term?
I can give you two really quick examples. I think one is that one of the biggest values that we see off of the programmable network is falling flash prices dictate that you have to have scale out to have good pricing on storage. You should buy it at the price that it is year on year. And so being able to program the network makes it possible to scale that system out simply, right? So just that's straightforward. The tiering thing is another area where it's really valuable to understand workloads and make good decisions about data.
For us, this is fundamentally important, right? I mean, you cannot manage what you cannot measure or what you do not measure. The ability to know exactly which app is using what, which are the top talkers, which VMs talk to each other the most, and then being able to apply affinity rules for the highest conversing. You don't want to see two VMs on either side of the WAN doing a lot of talking. You might as well move that architecture. So the ability for us to measure, in turn being able to have a programmable network that you can in real time be able to manipulate and rejigger the VMs. All these things start becoming very important at cloud scale. The ability to measure, the ability to fix, the ability to program and have a mobile application landscape. These all go hand in hand with each other.
So
For
one other,
programmers, more of a push. What feedback mechanisms that exist today are there to be leveraged?
so one other thing I just wanted to mention on that is that one of the things I'm working on right now is kind of essentially that problem, but how we're attacking it is with machine learning. So if you put together, you have data, you have ways of analyzing that data that may or may not be predictive, and then you have SDN, which makes it all actionable. There's a lot you can do to work to chip away at that problem.
I mean, CDN is a simple example of that, right? If you look at the telemetry of, just use Netflix in a neighborhood, what movies are getting downloaded, what's the most popular, then you start caching that stuff closer and closer to the edge, right? You can see it against all sorts of different usages for local breakout in your mobility applications. So the telemetry's there. We haven't been real good about using it because we frankly haven't been forced to, and now we're getting to that point.
So the telemetry is an area of particular interest for me as well. And that's one area where we're spending a lot of time and doing quite a lot of innovation, not only in software, but also in hardware in that space. We believe that it's important to have really pervasive view of what's happened in the data center. And also this, coming back to some of these problems with containers where they are quite ephemeral, they pop into existence, they disappear, is having a historical record of everything that's happened in the data center. And that needs to be pervasive. And it's important not only just to understand how you're going to be provisioning your workloads, but it's also important from a security perspective. It's an important from a planning, compliance. It just goes end to end. And we see a lot of value coming from the network in that space, in that the network is the one thing that touches everything else. And it sees where all communication comes from and where it goes to, when it comes, when it goes, and it may or may not know what the deep packet, because I think that's kind of hard to do with that kind of scale, but certainly it probably knows the dialects that are being spoken, i.e. the protocols.
Yeah, I think that's a good question. I just want to make one comment on from a Yahoo perspective. Absolutely, you cannot build state machines that have intelligence if you don't have a dialogue with the network and what state it's in, and in fact a dialogue with every layer. And so that's what that telemetry bus really is. You really have to break that problem down into time domains and granularities to do it right? You have to know if you need 10 millisecond resolution on a piece of data to make a very fast decision, if you need 1 to 5 second resolution on data. Do I need 1 minute resolution? Is it 20 minutes or whatever? And at Yahoo, that determines whether I'm going to fetch it off of a Kafka bus or whether I'm going to go out to a Hadoop cluster to get it, or whether I have to write some code that runs on an Arista that does it in a tight loop on the device itself. And I would just say that's a hard problem to solve, but it is actually absolutely fundamental. You can't just push configs out to a network without knowing the state, and you can't push a config out without validating that that config is working. And so that dialogue, that telemetry system you talk about, we used to think about it in terms of we'd have a tool that does X, and we'd have a tool that does Y, and we'd have a tool that does Z. And every single one of those tools spoke SNMP or APIs to the devices and had its own database and had its own UI and everything else and its own API. Nowadays, we talk about horizontal layers, right? So we have a project called Panoptes that my DevOps team put together, and all it does is fast polling of the network and fast data collection from the network and puts it into Kafka. And then we have 3 or 4 consumers off that Kafka. So it's very much about building that as a horizontal capability. Dino.
Yeah. So do you think that the OCP design or specified hardware and software will take market share away from the traditional equipment vendors? And if not, are you scared that it's a race to zero?
Let you guys comment on that.
Thanks, Dino. I thought you were a friend of mine.
Doesn't give a shit. What did you just say?
So certainly if a switch that's sold that's not ours, it's taking the market share from us. And so will the OCP switches have an impact on the traditional networking vendors? Yeah, I think that's going to be obvious that that's going to happen. But the way that we can participate, or the way that we can counteract that, we being Cisco, is we provide OCP switches, and we can play in this game. That's one of the reasons that my business unit spends a lot of time developing custom silicon, in that we are able to create silicon such that we can then build switches and price them to be competitive with the white box market. And that's a fundamental part of our overall strategy. In the end, everybody's buying silicon from TSMC. It's how many middlemen do you have in between before you can ship a box is what makes a big difference. And that's why we build our own silicon. So it's a big factor. We're going to be fine.
Yeah, I was going to
Yeah, so have open APIs so we can program your chips.
We've already done that. Okay. That's already out there.
Okay.
I must say, Dean, I understand the question. I do care, actually. I think Tom and I had this conversation many years ago. The cost of hardware in the overall scheme of things is not that high. I'd rather pay more for something that's reliable all day long. I think sometimes things like OCP and all are overrated. It's okay if you have a Facebook or a Yahoo where you're building stateless apps and the apps die, another instance comes up. For enterprise apps, you really need high performance infrastructure. You really need telemetry. You really need a whole bunch of capabilities that just pure or plain old, there's white box and there's vanity and there's white, and there's there's a time and place for both systems, I believe, in the long runs. And there's van or white too, yeah.
Yeah, and at HP, I would say a very similar answer, right? I mean, we're partnering with OCP. We have OCP partners, both in the switches and the server division. And to his point, you've got applications today that it's a perfect fit for. You've got other applications it's not such a great fit for. And, let's face it, the hardware's been a competitive market for ever. And so it just continues to drive, and you look for new innovation and other ways to make it up. And that's part of the reason you're seeing the shift to more and more of a software stack, right? And like I said, one of the reasons why I'm also looking at a composable infrastructure is where can you fit those right pieces? One, that satisfies the customer's need, and two, leverages the best innovation you can get out of it.
All right, go ahead, Dave.
I just want to say, being last in line, the only thing left to say is what those guys said.
Well, listen, I really want to thank you guys having Brocade, Coho Data here, HP, VMware, and Cisco. I just got the feeling we're just getting warmed up, and I'm keeping you guys from beer, wine, and cocktails. So I've got Ernie over here, and he looks pretty thirsty, so I'm going to hand the mic back to him. Why don't you guys give a round of applause to the panelists?
Thanks very much, Ryan.